All right, it cut me off. There's like 15-minute timing limit on it. It cut me off on the last one. Okay, so we're finding the total distance traveled. We found that it traveled 5 feet to the right. Okay, now we do from x of 0 to x of 1. All right, so x of 1 would be 2 minus 3 plus 2, which would be 1. So x of 1 would be 1. So in between 2 and 1, it traveled 1 foot to the left. Okay, and then it started traveling to the right again. We know that from 1 to 3, it was traveling to the right. So we're going to do x of 3, which I believe we found up here already. X of 3 was 32. Oh no, it was 29. Excuse me. Yeah, x of 3 is right. Here, x of 3 is 29. There's where good notation helps you, so that you don't just have random numbers floating around. So x of 3 is 29, and from 1 to 29 is 28. It went to the right again, but it doesn't really matter, right? So what's our total distance traveled? Well, our total distance would be 5 plus 1 plus 28, which is 29 plus 5, which is 34 feet. Okay, let's move on to number 17. See if I can get this all in one. Okay, we're going to use the calculator for this problem. And that calculator on the computer is just a mess. So let me get myself bigger here. Where am I? Oh, I'm not even there. Huh. Okay, so we all know that calculator app on my computer is not amazing, and it's really hard to understand, and sometimes it's hard to put stuff in. So we are just going to use my regular calculator. So hopefully this works. You guys love being my guinea pigs, right? Okay, so we are going to find some derivatives. So first we're going to go to our y equals screen, and we're going to plug that function in. 4 to the x minus 3x. Oh, and mine went all up in the exponent. You don't want to do that. Okay, so there we go. 4 to the x minus 3x. So you're going to enter that in, and then you're going to use the derivative for these problems. Okay, so find f prime. So we're going to go second, calculate, and we're going to go down to derivative. So I go to second, calculate. All right, let's see. Second, calculate, and it says calculate the derivative at a point, and we want to calculate it at 3. So we're going to put 3 in here and push enter. And our derivative of that point is 85.722. So that's what you write down. That's your derivative at that point. Okay, f double prime. We are going to, let me get this set up really quick. Okay, so did you know that we can graph the derivative? So here we have our function. I have it in here, okay? And now we want to graph the derivative and find out where, so this was our function, and we can graph the derivative, and now we calculated the derivative, but what if we just graphed it and then found out what that graph was equal to at 3? So to graph it, I'm going to try to do this where you can see. I have to go the opposite way. Okay, you're going to start by pushing math, and you're going to go down to end derive. Okay, we're going to push enter on end derive, and you see how I have my derivative menu there. So then I'm going to push x, and I'm going to derive. Well, what am I deriving? Well, I'm deriving that first function, right? So I'm going to go to vars, and we're going to go over, and we're going to select the first function. Okay, so we want to find the derivative of y1, and here's the cool part. X equals x. We put x equals x on there, and it will graph the entire function. Now, it's not going to spit out a derivative for us. These are still not that advanced to just spit out an actual derivative. That would be awesome if they were, but they're not. So we can do this, though. Let's see the graph. It'll take a minute, and it's going to graph the two functions. So there's our actual function, and now it's going to graph our derivative. And then if we go to trace, oh, it's still graphing. See the little thing in the top? Okay. All right, now if we go to trace and we type in 3, oh, nope, I want to trace the other function, don't I? Okay, so I got to push trace until my red function shows up. Or I need to, like, arrow. There we go. Arrow to my other function. And I trace 3. Oh, I still have to arrow over. It likes to jump over to the blue function. Okay. So I've already pushed trace, and then I arrowed to my red function. I pushed 3, and I pushed enter. See? 85.722, that's what we got before. Okay. Now we're going to find the second derivative, so we're going to graph the second derivative. So we go back to y equals, and we're going to graph the derivative of the derivative. Well, this function, y2, is the derivative, right? So let's graph the derivative of the derivative. So we're going to go to math, and we're going to go down to nderive. Okay, and then we're going to do the derivative with respect to x. Now, what function do we want the derivative of? We want the derivative of the derivative, okay? So we're going to go to vars, and we're going to select a function, and we're going to select our second function, because that's the derivative. Okay, and again, we're going to do x equals x. Now, remember, if you have the older calculator, we can go through that in class, how to put this in, okay? But it's the same process. It just looks different than this, okay? It's just a different order. So now it's graphing the second derivative. It's graphing it for us. And so then we can calculate it by tracing. Oh, is it still thinking? Yep, it's still graphing. Those are the graphs of the derivative, the function, the derivative, and the second derivative. And it's still graphing, and it's still graphing. Yep. Still going. All right, so we're going to trace. We're going to arrow over. Okay, we're on the black function, and we want the first or the second derivative at 1. So we're going to push 1, enter. And it is 7.687. Excuse me. Well, that was gross. Okay. So the second derivative at 1 is 7.687. Then we can graph. It says graph the first derivative. We already did that. So again, you're just going to go into your y equals, and you're going to put your derivative in, the derivative of the first function in. Okay. I think we're going to go back to our actual notes here. Oh yes, I forgot to make myself small before I did this. Okay, there we go. Let's make me small. Okay, all right, so let's take a look at the next one. Here we have, so if f of x equals 4 over 3x squared, find the average rate of change from x equals 1 to x equals 2. Okay, so average rate of change is not calculus. Average rate of change is just algebra. Okay, so this is just algebra, not calculus. Average rate of change is just the change in y over the change in x, right? So we're going to look at the average rate of change from x equals 1 to x equals 2. So we're going to say at f of 1, f of 1 is 4 over 3, so 4/3, okay? And then, so I would write this, I would say, okay, my first point, like if I was graphing this, right? Oh, it's not 4 over 3, excuse me, it's 4 over 9, because that 3 is squared. So it is 4 over 9, okay? And if I was graphing this, I could say that this point was at 1/4, right? Because that's where it lies on the graph. Okay, and then, let me pull this back up. And then we can just figure out what it is at f of 2, or at x equals 2, okay? So, f of 2 equals 4 over 6 squared, which is 36, which is 1/9. Okay, so again, I would write this as a point, 2, 1/9. Okay, so then we just figure out change in y over change in x, right? y2 minus y1 equals x2 minus x1. It's something we've been doing forever, okay? It's just that when we get the calculus in there, sometimes we forget that we're really just doing algebra, right? We know how to do algebra, and we know how to do calculus. Okay, so y2 minus y1, 4/9 minus 1/9 over x2 minus x1, which is 2 minus 1. So 4/9 minus 1/9 is 3/9 over 1. Okay, so 3/9 is 1/3. So the average rate of change, we could write A rock is 1/3. Okay, and then we're going to look at the instantaneous rate of change, which is, let me pull this up really quick just so that I make sure that I tell you the right numbers. Yeah. Oh, it should be negative. Did you see what I did there? I did y1 minus y2 and then y2 minus y1. That's a big problem when we do that. So really, we should have had, see, I knew, this is why I have the answer key there, just to make sure that I, like, in the moment, don't do the wrong thing. Okay, so that's going to be that. So instead of 4/9 minus 1/9, we have 1/9 minus 4/9. It's just that, so our average rate of change is negative 1/3. All right, and then the second thing asks us to find the instantaneous rate of change. Instantaneous rate of change is the derivative, right? It's the slope of the tangent line at a given point. Okay, so the instantaneous rate of change of this, well, let's rewrite this as 4/9 times x to the negative 2, okay, because that's really, that's the best way for us to differentiate this, is if we do it like that. And then we're going to bring the negative 2 down. So we have negative 8/9 times x to the negative 3. And then we are going to just plug in. So that's f prime of x is negative 8/9 x to the negative 3. And then we're going to plug in f prime of 1 equals negative 8/9 times 1, which is just 1. So our instantaneous rate of change is negative 8/9. All right, we will stop there.